Our next speaker will be Mr. Robert Kelley. Robert's the lead with the Standards and Assessment Group for Jacobs Jets and supports the orbital debris science and research operations supporting the NASA headquarters Orbital Debris Program Office. And Robert's going to talk to us this afternoon about orbital debris and end of mission policy and procedures. And then after that, we'll have a short wrap up, and then we'll go off for dinner. So, Robert, thanks.
And I guess that kind of gets me to the question of whether safety issues there are besides just human safety. My main role is to evaluate projects on whether or not they comply with debris mitigation policies. The good news is a lot of any mission that's not going into lunar orbit, most of these are just going to be recommendations. Some of them are going to be requirements for those that actually enter lunar orbit, and I'll cover those as we go. So, a quick picture of the orbital debris environment. Basically, orbital debris is anything that no longer serves a use in space. When you look at that picture, that's everything we can track. It's not the untrackable objects. It's clearly not to scale, but this is what we can see from the ground. There's a lot more up there than what that just shows, but it does give you a decent picture of how it's grown. So here is a nice chart that shows you how debris has grown over time. Starting in the 60s, you had really nothing up there. There was a fairly steady growth until we got to about 2007. In 2007, we had an event that resulted in a large jump in the amount of debris that was up there. And then in late 2008, we had another event that also created a lot more debris. So a fun little switch through the images to show how it's grown. Just launch more stuff, more and more trash has been left on orbit until you get to the point where it's nearly covered. 2010 is the last one we have up there, I believe. This is a good picture. What you'll notice is this only really ends at the geobelt. That's where we primarily, that's where most missions go. That's where we've spent most of the effort on enforcing it. There's not that many missions going to the moon. It's a low number. While there are requirements for things that are going into lunar orbit, one of the side effects of this project, of this group, is as we work with you guys to determine whether or not you meet requirements, there's going to be a degree of learning on our part because we haven't had to enforce some of these before. So the bottom line is the most important one here. The reason why we do orbital debris mitigation is to protect the Earth space environment for future generations so that it's useful. If we just keep leaving things up there, eventually we're not going to be able to continue launching. So the parent document is the NPR. It's a NASA procedural record. Defines out who's responsible for what and what documents are due at what point. The requirements of the Centennial Challenge only require that you follow the NASA standard and submit an orbital debris assessment report as defined in the NASA standard. So we'll kind of walk through those requirements. Basically, in your cases, you're not going to have to deal with the launch vehicle documentation. That's all going to be taken care of by DSLS folks. So you'll be responsible for the spacecraft portion of your mission. There's no requirement for at what point that's going to be due. Based on what I have, I'm not sure what the Centennial Challenge folks, where their milestones that they're going to make this due. It is a document that will be due. My recommendation would be to start it relatively early so you can think about some of these requirements and how to address them. So the first set of requirements, the 4.3 requirements, are releasing debris. These requirements are recommended for lunar orbit missions, and there's no recommendation or requirement for anything that's going out past the moon. So those missions would actually be exempt from these. It's still a good idea to try and follow them. The goal here is not, if you have to release debris, to try and keep it small and short-lived. Well, when you're that high up, it's not going to be short-lived. but trying to limit how much debris you're releasing would be the intent of this. For the 4.4 documents, these are required for all objects that are going to be orbiting the moon. In fact, they're not even a recommendation if you're going past the moon. Like I said, most of these aren't going to apply. The most difficult one to do here is accidental explosions. Your hardware needs to be reliable. And what you have to do to meet this requirement, if you're going to be orbiting the moon, is show that the likelihood that during your mission that you're going to explode is less than, I believe this number is 0.01. So you have to show that you're reliable. Passivation is the other one. You need to disconnect your batteries. You need to vent any propellants that you're going to have. And then the other, just turn off your spacecraft when you're done using it. The planned breakups, I would just hope that that's not something you need to consider. It's in general, it's not used very often, but and I don't really see how that would meet any of the goals here. So if you want to do a planned breakups, feel free to call. We'll talk to you about them. 4.5, on-orbit collisions. This is where it's going to be a learning curve for us as well. So large objects, there's not that many large objects either around the moon or out past the moon. There's a requirement that missions orbiting the moon do follow this guideline. So we're going to work with the people who do conjunction assessments, and we're going to try and help you guys figure out whether or not you meet this. Your likelihood of running into something large, I guess the problem would be now you're putting potentially a number of things all in orbit at the same time, so you might have to contend with any other vehicles that are going into lunar orbit at that point. And then small objects debris, limiting debris generated by small objects. The big issue here is it's things that would prevent you from doing intermission operations. In general, your intermission operations are going to be either to continue out into deep space, in which case that's not a problem, or to land on the moon, and gravity is going to take care of that. So there's not really anything, there's not an active thing you have to do for intermission here. So 4.5.2 is easily met. Disposal of space structures. The largest requirement here is if you are going to go into lunar orbit and you're not going to specifically state where you're going to land, you're going to need to notify NASA headquarters and let them know that, hey, we're going to be just randomly landing somewhere on the moon. The idea of this policy is to protect the heritage sites that are on the moon, and so they try to limit how many things are going to just randomly impact the moon. In the scope of this, the plan is just let the folks at headquarters know that this is what's going to happen. When you complete your ODAR, it'll be, if you're orbiting the moon, unless you do decide that you're going to do a targeted landing on the moon, it would be discussed at that point, and the permission is not going to be as difficult to gain as if it were a much larger vehicle. And then it's not year zero, so it's not an issue. You're not going to re-enter the atmosphere, so you don't have to worry about what your risk of the ground population is. The other one that is required for lunar orbit is going to be tethers. If you do design a mission that uses a space tether, you're going to have to evaluate that if something were to happen, that tether is not going to also create more debris as a result of it. And those evaluations are available. The problem is, much like the large object collision risk, we're going to have to look at how to evaluate those things. Most of our experience is dealing with LEO and GEO things, and so we have tools in place that will help to evaluate those. Some of these tools might have to be adapted to deal with lunar orbit. And then a document that is available that you can look at is the NASA Handbook for Limiting Orbital Debris. It describes what the environment is, it describes what the policy and requirements are, and it gives you an opportunity to understand where some of those come from. As with most of the policy, lunar missions are not covered all that well, and if you're going out past lunar, then it's not mentioned at all. And so, in general, the only real places you need to be concerned about these policies is if you're going into lunar orbit. But we would appreciate if you actually think about them when you're doing even the deep space missions, just because there is a benefit to limiting some of these things that you can create. And then my backup slides, most of those are just provided so you have reference there when the slides are made available. discussing debris assessment software, which actually doesn't apply to any of these missions. So that pretty much covers it. If anyone has any questions, yes.
The .01 requirement of occurrence of an explosion, that I would hope is associated with a time frame.
Pardon me?
The .01 requirement of not having an explosion, of the
Right.
likelihood, is that tied to a time frame?
That is, well, that's where passivation comes in. So it's during your active mission, you can't have the explosion, and then you should passivate so that it doesn't, so nothing else causes it to explode after that point. Yes, sir.
Regarding possible or intended collisions with the moon itself, are
Yes.
there no planetary protection requirements for the lunar?
There are protection requirements for that. I believe that's where it triggers that you have to notify NASA headquarters to say that you're going to be impacting the moon there.
As a result of that, are there PP requirements for sterilization of your hardware before?
Not for lunar. There wouldn't be sterilization, right? Yes, sir.
Yeah, but headquarters does care that you not impact heritage landing sites.
They do care.
They do care,
Yes.
right. So,
That's their goal, but most of these are small enough objects, and it's understood that there's going to be limited control on them. We would prefer that if you're going to build something to orbit the moon, you're going to know exactly where you're going to hit.
well, you can take it a step further, because if you're orbiting, you got there somehow by means of propulsion. So
Right.
you could ask users to hold out margin for an end-of-life maneuver.
With larger vehicles, that is something that would actively be required. In this case, I think some leniency will be granted on saying, you really should do this, but we can understand it's a smaller mission. Yes. In lunar orbit, it's not going to last in lunar orbit. It's going to be very stable, but you would, because it's going to randomly impact the ground, you are going to have to notify NASA headquarters that that's going to happen. And
all situations, I believe, a satellite order after shutdown, we can contact you.
yes, correct. Any further questions? Yes.
The questions, some of these, our intermission, in your intermission plan, you'll talk about where impact and stuff. And also some of the questions like sterilization and stuff like that are outside of the orbital debris, but they certainly be of interest to the planetary protection officer, Dr. Bergen.
Right, planetary protection would
And
be,
we share our intermission plans with planetary protection. Sometimes we have opposite opinions when we work those out, but when you put this in your intermission plan, so it's unique.
yes.
Did everyone hear the question?
No.
Robert, do you want to repeat, or Summer? Either Suzanne, maybe you repeat the question, or Robert, you can.
Well, it wasn't really a question. I heard some questions about impact, heritage size, sterilization. Sterilization is really not an orbital debris thing, but it's certainly a planetary protection question, and that how much more of the planetary protection officer will be calling in. And the intermission plan, with your plans, and that's required. And once they're prepared, we review them, and I also share them with the planetary protection officer.
And I believe the planetary protection requirements are one of the requirements listed for the Centennial Challenge documents.
Yes, there's a rule regarding planetary protection, and it cites the NASA policy document for planetary protection. And it is Cassie Conley from the NASA Planetary Protection Office who will be one of our speakers tomorrow morning. So she'll be able to address these details again in more detail.
My point is she'll also be looking at the intermission plan.
Sorry?
My point was the planetary protection.
She'll also be reviewing the intermission plans as well.
Yeah, so the intermission plan serves both purposes for orbital debris assessment and for planetary protection purposes. The bottom line for the Q Quest contestants is that they must have an intermission plan that addresses what they're going